I think I can make it a little bit bigger here. Is that a bit better? Yeah. So for example, like equals, what if equals, you represented it as an object? So you could say equal to 5, verify with 8. So what would happen if you did that? So see how this has come up and says constraint error, 8 not equal to 5. So that's kind of a very simple example. But often in your tests you get things like, well, maybe we want something to begin with something. So like, how about begins with, and then hello, error message for world, right? So let's try that one. So I don't have to highlight everything. I can just... So here it says, world should begin with hello. So you can see what's happened is I've created these objects that represent a lot of common sort of test situations and asked the objects to actually report the error message for me. And then I actually added a bunch of convenience methods. They call them loose methods. I can't remember what they called them in Pharo, just adding methods to objects. So should equal actually does what this does up here, this piece. It just kind of assembles one of those things for you, and then you get the same sort of idea. So, sorry? Not traits, where you add loose methods, where you add methods from another package. So basically what I'm doing is extending integer with should equal and that kind of thing. And then you can actually get into sort of more interesting cases where greater than 2 and less than 3, or greater than 2 and less than 3. So if I do that verify with 5, 5 is not greater than 2 and 5 is not less than 3. So it doesn't, you can sort of change. So again, what's happened here is this this translates to an actual object. So let's look at how I do that. So there's this constraints package here, and if I open that up in the package browser in Dolphin, if I look at constraint, and it'll do a little funky class diagram for me here. So you can see what I did was I created an object called constraint. Let me see if I can make that bigger for you as well. I think I can do it here. Perhaps that's a bit better. So constraint. So I had binary constraints where I had and or. I had independent constraints like any, multi-values. So I came up with different only, sequence, begins with, ends with, equals, greater, identical, includes. So as I was writing my tests, I sort of noticed it's like, oh, I haven't got one of these. And so I would add it and create a class for it. And the actual implementation for these is it's pretty straightforward. They're not. So satisfy, it just sort of says an object begins with, let's have a look at how that does it. Basic begins with, I think that's just a built-in method in sequenceable collection, so actually I didn't have to do anything. So you can sort of see it's just like, you're just turning some of these things, and then I've added an error message so that an object prints should begin with, and then, something else. If I look at equals, the error message should say something about equals. So, yeah, not equal to. So you can see that because you've got these objects now, you can start implementing behavior on these objects so that they can report error messages for you. So if I go back to my presentation here, I showed you that. So now what you get is, when you get a failure in your S unit, you can actually get something that you can read. So at the bottom here, it now says constraint error should include Peter. So I don't know what the test was. But you actually start getting interesting things in there. And I found that was actually quite helpful. So not only if I'm doing TDD, I'm expecting to get a particular kind of error, I can actually quickly check that I'm getting that error without having to launch a debugger. So it's quite a nice visual indicator. And then sometimes when you make a refactoring or something and something breaks, you can quickly click on something and see the error message. And if it's, if it kind of mentions something like Paul or something. You're thinking, where did Paul come from? I didn't have anything to do with Paul. And of course, it's not a member of that set. So I found that actually speeded up my my development and my debugging a little bit. So in trying to implement this, I did come up with a couple of issues. It turns out that I can't read it from here. I have to go back here. It turns out that test results don't store the exception that causes them. So that was a bit of a problem. So I had to go and change test result to add that. So this is something that I should consider folding back into to SUnit. And then the other thing is, if you do store the exception, how do you get a meaningful message from it? And this is where those constraint objects come in, because what you can do is start to query the constraint objects or ask the constraint objects to render their error message. And like I said, you can start to get interesting kinds of constraints and chain them together in interesting ways. So, begins with P, ends with, I talked about that. I started to find that often in my tests, it's like if I'm dealing with collections or things, I only want particular values, so I had only. Sequence, sometimes order is important. So, maybe you needed the sequence of Peter, John, Harry. And then when you've got these kinds of objects, you found that it refactors a lot of the stuff out of your tests. So like common patterns kind of emerge, and what you can do is kind of push them over to a constraint object. So your tests kind of clean up a little bit. You kind of find interesting behaviors. I'm sure that the guy that was doing the trading stuff here, I'm sure there's kinds of constraints that are very particular to trades that you could kind of code up, put them in the right hierarchy, and then you could sort of say, write much higher level tests, I think. That's something that I haven't proved, other than I noticed that sequence and set and that kind of thing was interesting. So, can you use these constraints for other uses? And I found, yes. I mean, sometimes I think with the method wrappers stuff, some people use method wrappers for testing. You could probably put some of these constraints in your method wrappers, and then they could report if they didn't get values that they were expecting. If you've wrapped a method, stick a few constraints in front. But the other thing that was interesting to me was this idea of using them for mock objects. How many of you know what mock objects are? Is that a familiar term? There's a kind of a few hands. So mock objects was something that I invented with some friends many years ago, and it happened in the Java world, actually. And what was happening was, it was when Agile had first started and we were trying to write good unit tests. And we noticed that actually we were writing lots of tests, but they weren't actually very good. I mean, there wasn't a lot published about what the C2 tests looked like. And so we were doing things like, we were adding get salary. We were adding lots of getters to our methods so that we could write those assert tests that I was talking about early. And it was okay, but it kind of felt a bit slimy. And particularly coming from the Smalltalk world, we tend to give responsibilities to objects. And so this idea of adding getters to everything, it didn't seem right. And my boss at the time said, no, he said, I'm not going to let you do that. He said, you've got to come up with some better way. He said, that's just a compromise too far. You're ruining encapsulation. And we sort of said, well, it's for testing. Anyway, we decided that we were going to have some experiments and try something. So what we talked about was maybe the onion peel of software, sort of, and this probably makes sense to Smalltalkers here, but to the Java world, it was something that was kind of new. And it was about, composition is actually a very useful mechanism for writing good software, but it's also a very good mechanism for writing tests. But then how do you access the functionality inside? So if I don't put getters in things, and I compose objects, how could I write interesting tests? We still weren't sure. So we played around a bit, and we sort of rediscovered the composition thing. We discovered interfaces, which I guess are sort of like the protocols that we would use in Smalltalk. And this idea of expectations came up. And this work kind of came around from doing lots of different experiments. And the idea that we came up with for what we termed mock objects was, say, for example, I've got this trade agent object, and I'm sort of thinking, well, I want to write some tests for it. So what does a trade agent do? So maybe I'm trying to think, well, I want to kind of buy some trades from a market and then, take some money out of a bank account or something. So maybe I write a test for test buying the cheapest. And so, maybe we kind of talk about that as a pair, and we say, okay, well, maybe we're going to need a stock exchange. So the trade agent's going to go to the stock exchange and, buy some trades and then take some money out of a bank account, right? So then remembering is like, well, actually, the object that I really want to test is this trade agent, and I'd like to kind of test it in isolation because maybe I haven't written the stock exchange, or I haven't really thought about all the details of a bank account, but this is the main thing that I want to test. So the idea was, if I was to sort of call buy cheapest on trade agent, what actually would he need to do? So you might sort of say, well, I'm expecting a call to this stock exchange for 5 buys, and this could be a constraint that I could put on that particular object. And you'll notice it's very faint here. I put mock in front. And so the idea was, what if we had a pretend stock exchange and we were able to put a constraint on it that said, I expect a call for 5 buys. So if I get that call, then that's cool. And maybe if I get that call, I could say, well, actually, what I'm going to start out with a value of £5,000 or something. That's what it cost you. So that could come back. And then I could set another constraint on the bank account and sort of say, well, I expect a debit for £5,000. And if that's okay, test wouldn't fail, then I would say, yay, I've implemented everything. And so the idea was that by composing things, by sort of saying that a trade agent is also composed of a stock exchange and a bank account, I could actually put in fake implementations of these things that were instrumented with these constraint objects. So I could actually sort of, while I was writing the test, I could say, well, I am expecting 5 buys, and if you get 5 buys, if you do call me, then I'll say that everything's fine, and I'll return a value for you, and then I could set a constraint on the bank account and say, because you did 5 buys, you should be asking to deduct £5,000 from your bank account. And if you did 6 buys, then the constraint could immediately fail and sort of say, no, actually, I only expect 5, and you told me 6. And your test could fail with a very clear error message like I was showing you before. And that was kind of the big idea behind mock objects, was without using real objects, you could use these constraints to write good tests, which would help you work out the implementation of the main guy without being distracted by these other objects. Of course, later on, you could then move to the stock exchange object and then write some tests against him and do exactly the same thing again. And what we found was that using this technique, we found that we were able to create better programmers. So we had a number of students that were working with us, and they often got confused. And I guess I asked the question, how many of you use CRC cards? There's a hand there. I mean, it's a wonderful technique, and actually, if I go back to this guy here, you can start to imagine how CRC cards could play with this, because if we were doing a CRC session, and for those of you who don't know, CRC cards is literally taking some index cards and role-playing objects, right? So you could say, oh, well, if you're the trade agent and I ask you to buy the cheapest, what are you going to do? And you're the trade agent, you might say, well, actually, I need to go to the stock market and find the price of the trades. So there's a stock market object, right? And so you could hand that responsibility to someone else. And so it's nice if there's someone else that you're pairing with that does this. So they hold on to that card. And then you say, okay, so what are you going to do? And then, they sort of look around the room and sort of say, well, I'm going to give you this value back, etc. So you start to see that using CRC cards matches nicely with this and kind of gives you a nice object-oriented design. So we were using it for testing. And so what we found was that when we used CRC cards and we used this mock objects technique, that these programmers that were struggling with writing tests, the problem that they were having was they'd forgotten what they were trying to test. And if we said, okay, well, let me see your CRC cards, and they'd say, oops, we didn't do a CRC session, so we'd get them to do that. And then we'd say, okay, which object are you trying to test? That guy. Well, if you're trying to test that guy, why have you got a bunch of tests in all of these other things? So when we cleaned that up, we found that we started writing much better programs. They were much more modular, there was much richer objects with responsibilities, and so we found that the code was actually quite nicer. But the side effect of this was that we also found that we were writing better tests, and better tests that when they failed with very good error messages, so that when something went wrong, you could say, ooh, actually, it's failed because I didn't expect a buy for 6 trades. It was only supposed to buy 5 trades. So that was sort of the idea. So what I want to do is a little demo of TDD using mock objects and these constraints and kind of give you a feel for that. Now, when I tried doing this myself, I found it was quite difficult to type. So what I've done is I've recorded a little session. So I'm hoping that this will work out all right. So if I go to, so here. Can you guys see that? Is that okay? So this is something I did earlier. I'll read out the message and explain what's going on, but it just saves you watching me painfully type out writing a test. So what I'm going to do here is I'm going to click on next. So basically what's happening is I'm creating a test class. And there's a superclass of mock test case, which kind of gives a little bit of this setup behavior so that you kind of get a few things for free without having to type them out. So we create a test method. And so in this case, what I'm thinking of, actually I should go and just explain something. So I'm going to kind of simulate a little sort of project that is something I keep meaning to do and I haven't actually done it, was if you've got a lot of tests for a class, you could write something that would find those tests, take the names of the tests, and print out some documentation for you. So, if you had like that trade buyer object, you could say a trade buyer is, go find the names of all of the tests, take the word test off the front of it, maybe take the camel case, put a few spaces between it, and it could be a trade buyer is, something that buys the cheapest trades, something that reports if the stock market is closed, something is. So you can sort of see with the idea that I was doing. So the idea here was we did a CRC session and we said, okay, there's this documenter object and it's probably going to need some sort of name parser to parse the names of the tests, put those spaces in, and then there's going to be some sort of write stream that I'm going to write the results on. So that was the sort of the idea there. So if I go back here now, so there's my documenter object. So I've started thinking about that test. So if I click on next here. So I'm sort of thinking, okay, so what I'm going to do is I'm going to say to the documenter, process these methods using this name parser onto this report. So, and you can see that Dolphin has helpfully put some red lines under these things because there's no variables in that method. So the first thing to do is to autocorrect that. So there's a little option to autocorrect, so it's kind of put all the variables in place for me. And then I'm thinking, okay, so I've got these methods. Where do those come from for my test? So in this case, I thought, well, to get something going, I'll just make an array of strings, right? So I've said methods equals an array of strings, and I've put a few kind of test methods. It could have been, and this is probably a bad design thinking about it afterwards, I probably should have had some object that I asked the methods for, and that would probably be an improvement that you would do in a later test. So what I've done now is I've actually got this bit sorted out. So I'm going to call the documenter, I'm going to give it these methods. So what about the name parser in the report? Well, they're a bit more complicated objects, and I haven't really delved into what they're about yet. So maybe what I do is I just sort of say, okay, well, why don't I create a mock version of these things? A mock is just a pretend version of this object that I'm going to explore what I want it to do. So when I inherited from mock test case, there's this instance variable called mockery, which is a bit of a joke, but anyway. We asked the mockery to create us a mock, and we've called it a test name parser. And then the same thing for report. I've said to the mockery, create me a mock and call it responsibility report. So these are names of classes that I haven't created yet, but I'm thinking, if I go back to my diagram, I'm thinking, yeah, I needed those in my CRC session. I thought those would be useful objects. So I've created those ones. And then the next thing is, if I click, I need to specify some expectations. So this is where my constraints come in. So there's a whole bunch of different useful things that I found were interesting when writing these tests. Maybe I expect exactly a call like this, or maybe I expect one call to buy trades or 5 calls to buy trades. So there's a bunch of useful completed methods that a mockery can do for you. So we're going to pick one here. So we're going to say exactly like. So what I'm saying is I want exactly X number of calls like, and I'm going to give a block closure that kind of describes what I expect to happen, and then there's the opportunity for me to answer something. So let's fill that in. So I'm saying I'm expecting 2 calls because I had 2 test methods. So I had, test handles something, it's blocked behind there, but that array of strings, there were 2 test methods, so I expect the parser to get 2 calls to parse for each one of those names. And then I'm going to give an example of what I expect that call to look like. So I'm saying name parser parse. So I'm expecting a call to, I'm sort of giving that a name. And then I can put some constraints on the parameters to that parse method. So again, some of these things that I showed you before, the ands and the ors and the begins with. So in this case, I'm expecting it to parse a kind of string. And I'm also expecting it to, so you can see I typed only use, and I've got those two strings. So I expect it's a kind of string, and it's only one of those two strings. So that kind of gives me a bit of a test to go with. And then in this case, I'm just going to answer some arbitrary strings. It doesn't really matter what's answering. I'm sort of deferring some responsibility to something else. But to get my test working, I'm just going to give it some results. And the interesting thing is, with these results, I expect those to be handed back over to the reporter. So I'm giving an example here. I'm expecting two calls where the report says print responsibility, and it should be one of those strings, and it shouldn't have the word test in front. So if my name parser has worked well, it will have taken the word test off the front and written it out onto that output stream. So I do that. I get a few warnings about some uninitialized stuff in Dolphin. Same with Pharo. When you press save, it would kind of pop up. So Dolphin kind of does it more in line for you. Gives me the opportunity to create the class. I could have done this in the debugger as well, so you could run it and obviously get create something in the debugger. So here it's creating it. And so now we can run our test. Now, interestingly, I haven't written any code yet, so I'm expecting it to fail. So boom, yes, we get a red failure message, which is good. We like to see a failure when, if it passed, that would be like, oops, what have I done wrong? So I can go back and actually fill in the implementation of that process using onto method. So, I think about, okay, well, what I'm going to do is I'm going to iterate over each of those methods, and I'm going to ask the name parser to parse it. And then I run my test, and it fails again. And this time I can look at my message, and it says it was called too little. It expected exactly 2 calls. So what happened there then? Well, it's true. We started iterating over the methods, but we didn't actually tell the report to print the responsibility of the name parser. So I add that. So I say, okay, so report print responsibility of the result of asking the name parser to parse the name of a method. So now when I run this, so I press Control 1 in Dolphin, and it just immediately finds the tests, runs them, and hurrah, I've got something that's working now. So then I can go and maybe create another test and say, well, sometimes in these S-unit tests, I have things like setup, tear down, so I kind of want to ignore those ones, right? So let's write a test for that. So I can improve my code. So here I'm changing the method, so I'm saying I've got setup and test calculates. So in this case, I only expect one call to the name parser, because it should ignore that setup method. So at this point, I'm sort of asking myself, well, how is it going to know if it's a test method or not? So then I can write another expectation. Actually, just kind of fix that. So it's just expecting the 1. So now I can say I expect exactly 1 call to the name parser. Oh, sorry, actually I expect 2 calls, because I'm going to ask each of those test methods. I'm going to ask the parser, is it a test method? It may well be that there's a better way of doing this, but it was a handy thing to have. So again, I sort of follow that same pattern. I expect exactly 2 calls like name parser is test method, and in this case it should only call it with one of those test methods that I'd put in that array. So now when I run it, I get 1 failing test and 1 passing test. So that's interesting, what happened there. So again, if I look at the bottom, the constraints are telling me that setup equals test calculate. So there's something about setup that's going on there. So if I go back and look, it's like, the other test. Oh, sorry, actually, I didn't actually implement the code there. I'm getting ahead of myself. So I actually didn't implement the bit. The first test that I wrote was still passing. The new test that I wrote was failing. Now when I actually implement that is test method, so it ignores setup and tear down, I get 1 passing test and 1 failing test. And in this case, what's happened is I need to go back to my old test. And just add, because I'm dealing with fake objects here, if I go back to my thing, if you remember, I'm still playing, I haven't implemented these guys yet. They're just these mocks that I've just instrumented with some constraints, right? So basically, I've got 1 test where I didn't tell it what to do when it says, is it a test method? So I needed to add that to my other test as well. And then when I do that, I get my 2 passing tests. So here's the interesting thing, right? So if I go back here, so and you would do more and more of that. You kind of get all your test cases for this guy, and you get all excited. It's like, okay, I've got him working. And then you suddenly realize, well, actually, I haven't implemented these guys yet. So it's all working in theory with tests, but I haven't actually implemented concrete implementations of these. So really what I need for a running system is to go and maybe implement that name parser for real, right? So you're thinking, okay, so I'll go and create that class. Now, what did I call that class again? It's in my test, isn't it, really? Because I did specify it. And not only that, what were the methods? Because this guy started saying, well, he's asking this guy to be responsible for a few things. And if you recall, I think we called it was is test method, or did we call it is a method test? And then there was something about parse. Was it parse with one parameter, two parameters, this kind of... So then you start thinking, it's like, well, I've got all of this information encoded in one of these tests. So let's go back and look at one of those tests again. So if I go back over here and look at one of these tests. So one of the tests that we wrote here. Okay, so we called it an S-unit name parser. I don't know if you can see that there. And we said that we expected a parse method. So it was called a parse method. And actually, I did two variations of this. Sorry, I'll go back to this one. So we said as a part, and we also had this thing is test method. So that is actually the responsibility. That's the protocol that I'm expecting from that S-unit name parser. Now, wouldn't it be cool if it could just generate that for me? And so this was the interesting thing. So if I run this here, so I'll run it live for you. So this is running live. What if I held on to all of those mock objects and all of those constraints, and then I used them? So over here, sorry, if I pick a test, if I right-click, if I pick these tests, I added this generate code. So what the generate code does is sort of say, okay, well, I'm going to ask the S-unit framework, what were all the... Well, actually, I'm going to ask that mockery object, what were all the mocks that you created? And so the mocks that we created in this case were a responsibility report and an S-unit name parser. So if I pick that S-unit name parser, I could actually visit all of those expectations that I wrote and actually ask I could ask the expectations to create a method for me, and each of the expectations has got a bunch of constraints about that method, and I could ask each of those to generate the parameters for me. And so that's what I do here. So if I press OK, and I browse it, it actually creates me an S-unit name parser, and it creates me the two methods, is test method and parse. And you notice here, I'm just putting param1. But it does occur to me that I said that was supposed to be a string, and there was a few other expectations that I put on. So I could actually use that information to generate something more interesting. And that's as far as I've gotten. I took that and then I started writing more code and fleshing out the next object, right? So then I would go back over to this guy. I've now generated him so he becomes yellow, and I can start repeating the same process. So I can start writing some tests against the S-unit name parser. And maybe the S-unit name parser needs to use, I don't know, some parsing thing, smack or something like that. So I could maybe compose him of some other things and do the same thing again. At some point you get to leaf objects that just don't have any composition at all, and so you can just write some normal tests, not even using mocks with those. But you flesh him out. And then you go down to here, and you generate the code for him, and you write some more tests with him. So I thought that was kind of interesting. At the moment, it's just written in Dolphin. I should probably port it to Faro or to Visual Works. It's one of those things that I keep meaning to do, and I would love it if maybe someone would tap me on the shoulder and say, hey, I'll help you with that, because I'm actually not very good at Faro. I keep trying to learn it, and I haven't gotten very far. But I've been running the tutorial, so I'm going to get there in the end. And it's available on my website in Dolphin, but like I said, I'll make it more widely available, and maybe it could be used for something else. So if I could just go back to my slides here. So the other thing that I noticed was, actually, after I wrote a bunch of these tests, I did notice that it was kind of awkward having all these expectations at the beginning, and I thought it was much more readable to move them down to the bottom. So you can see here I said documenter process using onto. That was the main core method that I was calling. and then I set my expectations afterwards. So I said expecting, and then I just did a bunch of blocks. And that was really easy to do. I just added some methods to block closure and just made it so that you could compose block closures. And what it does is when it actually runs this, this expecting method evaluates all of these things first and then runs that piece up there. So it just kind of runs them in another order. But it was something that I noticed that it just made things a little bit more readable. So I think there's perhaps more constraints that could be written. I think that maybe we could generate better code from those. I mean, I'm not sure, but it kind of felt like it was interesting. I also thought that maybe you could use the constraints to see if you wrote conflicting tests. It might be possible to say you wrote a test that expected a method to be a string, and then you wrote another test that said you expected it to be a number. You could have conflicts there that you might be able to kind of detect in some way. So there's a few things that could happen there. And that was all that I wanted to say. So I don't know if there was any questions or comments from the audience. A question over there in the corner. Yep, please. Up.